Magandang araw. Ngayon ay tatalakayin natin ang partial differentiation sa subject na differential calculus. Sa mga naunang topic natin, kadalasan tayo nagdi-derivative in terms of x. Gumagamit tayo ng d over dx dahil ang function natin ay kadalasang may x variable lamang. Pero paano kung yung ating function ay mayroong more than one variable? So for example, yung ating function ay in terms of x and y na. So, ano na yung gagamitin natin? Magdi-derivative ba tayo in terms of x or in terms of y? So, dito papasok yung tinatawag nating partial differentiation, kung saan maaari tayo mag-derivative in terms of x or y, or kung ano pa yung variable na nandun sa ating function. So, magkakaroon tayo ng tinatawag na partial derivative of the function with respect to x and partial derivative of the function with respect to y. Pero ano ba yung mangyayari kapag nagkaroon tayo ng partial differentiation? So, sa partial derivative of the function with respect to x, i-derivative natin yung function in terms of x at lahat na ng other variables na meron tayo ay iti-treat natin as a constant. Ganon din sa partial derivative of the function with respect to y. Magdi-derivative tayo in terms of y, and then lahat na ng ating ibang variables dun sa function natin, iti-treat na din natin as a constant. So, ano yung ibig sabihin nito? So, para mas maintindihan natin, sagutan natin yung unang problem. So, narito yung ating unang example. Meron tayong function na in terms of x and y. So, hanapin natin ang derivative or partial derivative in terms of x, and then hahanapin din natin yung partial derivative in terms of y. So, ganito nga pala yung symbol for partial derivative. So, tulad ng sinabi natin kanina, so lahat ng variables na hindi x dito sa ating partial derivative of x, iti-treat na natin as a constant. So, try na natin kunin yung kanyang derivative. So, derivative ng x squared. So, alam natin na ito ay 2x. So, ito naman, minus 3xy. So, dahil yung y, iti-treat natin as a constant, pwede nyo itabihan sa 3y, then, ang derivative ng x lang ay magiging 1. So, ibig sabihin, magiging negative 3y na lang ito. Then, yung 2y squared, so, dahil wala tayong x ditong variable sa term na to, so, alam natin na ito ay magiging 0. And then, yung negative 4x natin, so, alam natin, negative 4 ang kanyang derivative. Yung 5y, walang x, so automatic, 0 din. And syempre, yung 12 or negative 12, 0 din. So, yung ating partial derivative in terms of x ay magiging 2x minus 3y minus 4. So, kung kunin naman natin yung partial derivative in terms of y ng ating function, so, lista natin as partial derivative of function with respect to y. So, yung x squared, wala tayong variable y dyan. So, tulad din ng ginawa natin kanina, lahat ng terms na walang y, so lahat ng variables other than y, iti-treat na natin as a constant. So, yung x squared, so derivative ng constant, so automatic, yan ay magiging 0. So, yung negative 3xy naman, so iti-treat natin yung 3x dito as a constant. Dahil yung derivative ng y with respect to y ay 1 lang, so magiging negative 3x. Then plus 2y squared, so alam natin ito ay magiging 4y. Then yung negative 4x, iti-treat din natin yan as a constant. Yung 5y, dahil meron siyang y, alam natin ang derivative nito ay 5. And then syempre, meron din tayong derivative ng constant na 0 ulit. So, ang magiging partial derivative ng ating function with respect to y ay simply as negative 3x plus 4y plus 5. So, ganun lang kasimple yung pagpa-partial derivative kung ganito yung mga function natin. So, hanapin lang natin yung variable at kung mga variable na iti-treat natin as constant. So, kung in terms of x tayo magdi-derivative, lahat na ng other variable ay iti-treat natin as constant. So, kung sa y naman, so lahat ng hindi y variable, so iti-treat na natin as a constant. So, another example tayo. So, meron tayong function na w, which is equal, or meron tayong tatlong variable dito. So, ibig sabihin yung w natin ay in terms of x, y, and z. So, yung tatlong variable na to, pwede natin siyang hanapan ng partial derivative. So, ibig sabihin, kukuha tayo ng partial derivative in terms of x, partial derivative in terms of y, at partial derivative in terms of z. So, try natin sagutan. So, unahin natin yung sa x. So, tulad ng step natin kanina, lahat ng variables na hindi x, ititreat natin as a constant. So, meron tayong partial derivative of the function w with respect to x. So, yung una nating given, meron tayong x squared y. So, yung y, treat natin as a constant, then derivative lamang ng x squared, which is equal to 2x. So, meron tayong 2x y. So, yung second term natin, negative 10y squared z cubed. So, wala tayong x dyan. So, ibig sabihin, 0 yung kanyang derivative. So, ito naman, plus 43x. So, alam natin magiging 43 ang kanyang derivative. At yung last term natin, negative 7 tan 4y, dahil wala siyang variable na x, so alam natin magiging 0 yung kanyang derivative. So, yung ating partial derivative in terms of x ay equal din sa 2xy plus 43. So, ngayon, hanap naman tayo ng partial derivative in terms of y. So, partial derivative in terms of y. So, yung first term natin, meron tayong x squared y. So, pag derivative natin yung y dito, alam natin ito ay magiging 1. So, 1 times x squared is equal to x squared. Then, yung pangalawa naman, meron tayong negative 10y squared z cubed. So, alam natin na yung z cube, i-treat natin as a constant. So, ibig sabihin, ikakopy lang natin yan. So, negative 10 z cube. And then, yung derivative ng y squared natin ay equal din sa 2y. Then, yung 43x, dahil yan ay isang constant, dahil wala siyang y variable. So, wala na magiging 0 lang din yan. And then, yung negative 7 tan 4y. So, alam naman natin yung derivative ng tangent ay secant. So, negative 7 secant squared. Copy yung angle 4y. And then, anong kulang? Ang derivative ng ating, or nasa loob ng parenthesis, which is equal to 4. So, magiging partial derivative natin in terms of y ay equal din sa x squared minus 20y z cubed minus 28 secant squared 4y. So, dahil mayroon pa tayong isang variable, pwede pa tayong manguha ng isa pang partial derivative. So, yung partial derivative in terms of z. So, mayroon tayong partial derivative of the function w with respect to z. So, yung x squared y, wala tayong variable na z dyan. So, automatic, ito ay isang constant. Or titreat natin siya as a constant. So, yung pangalawang term naman, negative 10y squared. So, dahil mayroong z cube dyan, so, negative 10y squared. Then, derivative ng z cube na equal din sa 3z squared. Then, yung kasunod natin, alam natin na yung derivative nito ay magiging 0. And then, negative 7 tan 4y, dahil wala ulit na variable z dyan, magiging 0 lang ulit. So, ang magiging partial derivative natin with respect to z ay equal sa negative 30y squared z squared. So, yun yung magiging proseso ng partial differentiation kapag more than 2 variables. So, ibig sabihin, pwede tayo makuha ng another partial derivative kapag, or depende sa dami ng variables na meron dun sa ating function. So, siguro isa pa tayong last example na tayo. So, meron tayong function z na kung saan in terms of u at in terms of v. So, ibig sabihin, meron tayong pwedeng makuha na dalawang partial derivative. So, dahil meron tayong fraction dito, pwede natin itong gamitan ng quotient rule. So, kuha tayo ng partial derivative of function z with respect to u muna. Yan. So, alam naman natin yung partial or yung derivative ng isa or yung quotient rule natin. So, ikakopy muna natin sa taas yung ating denominator. So, u squared plus 5b and then derivative ng nasa taas. So, equal. So, derivative ng 9u with respect to u. So, alam natin yan ay magiging 9. So, minus copy natin yung nasa may taas or yung numerator natin na 9u. And then, i-derivative natin yung nasa baba na u squared plus 5v. So, tandaan nga lang natin, dahil nagdi-derivative tayo in terms of u, yung u variable lang yung mahalaga. So, yung u squared, magiging derivative nito ay 2u. Samantalang yung 5b, dahil meron siyang v, alam na natin na iyan ay magiging constant dahil wala siyang variable u. And then, i-squared na lamang natin yung function sa baba. Dahil ito yung formula for quotient rule. So, pag sinimplify natin ng konti, meron tayong 9u squared plus 45b minus 18u squared all over u squared plus 5b then squared natin yung quantity na yan. So, pag sinimplify natin ng konti, yung partial derivative of the function c with respect to u ay magiging, so pwede natin pagsamahan yung dalawang may u squared. So magiging negative 9 u squared plus 45b all over u squared plus 5b squared. So meron na tayong partial derivative in terms of u. And then pwede rin natin kunin yung partial derivative in terms of b. So, similar din, dahil ito ay fraction, gamitan lang din natin ng quotient rule. So, meron tayong partial z with respect to v. So, ganun din. Copy natin yung ating denominator as sa una, sa pinakataas. u squared plus 5b. So, then derivative natin yung numerator natin, yung 9u with respect to v. Pero kung napapansin nyo, wala siyang v sa numerator. So, ibig sabihin, iti-treat natin as a constant. So, ang derivative ng constant, 0. Minus, copy natin yung numerator natin. Then, derivative naman ng nasa baba. So, yung u squared, wala siyang v. So, automatic, ang derivative ng u squared with respect to v ay 0. Samantalang yung 5b naman, pag dinerivative natin, ito ay magiging 5. Then, syempre, last step na lang, i-squared lang natin yung quantity ng denominator natin. So, u squared plus by b, yung quantity na yan, squared lang natin. So, magiging partial derivative ng ating function c with respect to b ay equal din sa, so dahil ito ay 0, makakancel lang yung unang term natin. Then, yung 9u times 5 is magiging negative 45 u all over u squared plus 5b, yung quantity na yan, squared na lang din. So, yan yung magiging partial derivative natin ng function with respect to v. So, ibig sabihin, pwede natin gamitin yung mga formulas at yung mga techniques na ginagamit natin sa normal na pagdiderivative or sa mga naunang topic natin sa differential calculus dito sa partial differentiation. Ang pinagkaiba nga lang, dahil meron tayong multiple variables, lagi nating tatandaan na iti-treat natin yung mga ibang variable depende kung ano yung pang-derivative natin.